Okay, this lesson is on factoring polynomials. And factoring is where you write a number or a polynomial as a product. And a product is when you're multiplying things together. So as a very basic example, if I have the number 10 and I factor it, I'm going to write 10 as the product of 2 and 5, 2 times 5. Okay, so it's a bunch of, I'm writing as a bunch of multiplications together. But we're going to do that with polynomials here. The first step in factoring is to factor out what's called the GCF. And the GCF is short for the greatest common factor, or the largest common factor, which is mentioned quite a bit in elementary algebra. Let's do some examples of that. Let's say we have 4x minus 12. I look at both terms, the 4x and the negative 12, and I notice that what I can do is I can factor out a 4 out of both of those numbers. 4 is the greatest common factor. What's left if I factor 4 out? Well, think of it as division. If I take 4x and I divide by 4, what's left is just an x, so x goes here. If I take negative 12 and I divide by 4, that leaves me with a negative 3 in there. And I factored the polynomial. It's 4 times x minus 3. If you are unsure, let's get rid of that there. If you're unsure that you factored correctly, the check is if you distribute the GCF back in, you should get the original problem back. And we do in this case. So this is the factorization that we're looking for here. Be careful of this error. If I take 4x minus 12 again, some students may factor a 2 out, which is correct. You can factor 2 out everything, but that would then leave you with a 2x minus a 6. Though this is factored, it is not completely factored. Because if you look inside the parentheses here, you could factor another 2 out. So we don't want to make this mistake. We must always factor out the greatest common factor. Here are some more examples. 15y minus 60. The greatest common factor would be a 15. If I take 15y and I divide away 15, that leaves me just y. And 60 divided by 15 is 4. And so I factored out the GCF there. Here's another one. 9 plus 18m. I can factor 9 out of both of those terms. The leftovers go in the parentheses. Now always think of this as division. 9 divided by 9 leaves you with a 1. 18 divided by the 9 leaves you with a 2 and an m. 9 divided by 9 is 1. Don't make the mistake that some students make and write a 0 right there. You don't want to put a 0 there. Okay, so there's our factorization. Here's another one. Oh, where'd it go? There it is. 9z to the 4th plus 27z. Now for the numbers 9 and 27, I could factor 9 out of both of those. Now with variables, you have to just go with the smallest exponent. So since I have just a z to the 1st right there, I can take at most a z out of both terms. If I do that, 9z to the 4th divided by 9z leaves you with a z cubed. And 27z divided by 9z will leave you with just a 3. And I factored the polynomial again. Here's another one. Okay. Now, since on this one the leading term or coefficient in the leading term is negative, I'm going to factor a negative GCF out. For 3 and 18, the GCF would be a 3. but I'm going to factor out a negative 3 here. Let's look at our variables now. I got a z to the 5th and a z cubed, so that means I could factor out a z cubed at most. I've got a w squared and a w to the 4th, so w squared at most will come out of both of those. This is my GCF. Now for the leftovers. If I take this term and I divide by negative 3z cubed w squared, that will leave me with a z squared, and no, that's it, just a z squared there. If I take positive 18 right here and I divide by negative 3, that will leave me with a negative number, negative 6. Z cubed over z cubed, that's 1, that's gone. W to the 4th divided by w squared leaves you with a w squared. And there's my polynomial factored. There it is right there. Let's try one more of these, of this type. 15y cubed z cubed plus 27 y squared z to the 4th minus 36 y z to the 5th. Okay. The numbers first of all. 15, 27, and 36. The largest number that will divide all of those would be just a 3. So I can factor 3 out. Y cubed, y squared, and y. The most I can take out is a y to the 1st. Z cubed, z to the 4th, z to the 5th. So at most a z cubed, the smallest exponent. There's my GCF. Leftovers. 15 divided by 3 is a 5. A y cubed divided by a y is y squared. Next term. 27 divided by 3 is a 9. Y squared divided by y is a y. And z to the 4th divided by a z cubed is a z. And last term, minus 36 divided by 3 is 12. Y's are gone, and I got a z squared left. There's my factorization. Right there. Okay, so whenever you're factoring a polynomial, the very first thing you always look for is a GCF. Now this is the same thing, though it looks a little different. X times x minus 3 plus 2 times x minus 3. Notice that each term has a common factor of x minus 3. Right there. So I'm going to factor that out just like I would any other common factor. I'm going to factor it out in front. And the leftovers go in the other set of parentheses. And the leftovers would be this and the plus 2 here. So I put x plus 2 right there. And I have it factored. This would be the same as if I had something like this. Let's say I had a 3 times x minus 3 times 2. Well, I have a common factor of 3, and so I'm going to move the 3 out in front. And then the leftovers, the x minus the 2 there. X minus 2 is the leftovers. So I'm doing exactly the same thing right here. Here's another example of that. Let's say I have y times x plus 5 minus 1 times x plus 5. Since each term has a common factor of x plus 5, here and here, I'm going to factor it out in front, like that. And then the leftovers, which are the y and the minus 1, will go in the second set. And once again, I have it factored. Okay. Now, that leads us into factor by grouping. And factor by grouping is usually used when you have 4 terms. Here's our first example. Let's say we have 2k plus 2j. Oops, sorry, that's wrong. Let me fix that. Erase that. 2k plus 2h plus jk plus jh. There we go, lots of variables in there. Okay, the first thing I look for is a GCF, and notice that there's nothing that I could factor out of every term, except a 1, but then that wouldn't change anything. So basically no GCF here. But what I can do is I could group the first two together and the second two terms together. Make sure that when you do this, you do leave a plus sign in between. If you don't, it looks like multiplication. You don't want to do that. Out of the first group here, I can factor something out. I can factor 2 out, and it leaves me with k plus h. Out of the second group here, I can factor something out. I can factor out a j. That leaves me with k plus h in there. Now I've made this problem look like the previous two problems. Notice that each term has a common factor here of k plus h. And so I'm going to factor it out, move it in front. There it is, k plus h. And the leftovers go in the other set of parentheses, which are right here, the 2 plus j. And I factored the polynomial. If you needed to check, this is what you would do. K plus h times 2 plus j. If I multiply that together, I could use the FOIL method here. That's 2k, that's jk, that's 2h, and that times that is hj. That is the original polynomial up here. It's in a little bit of a different order, but it's basically the same terms. Okay, so when I multiply it out, I should get the same thing back, and I do. Right, so here is the factorization of the polynomial. Let's try another one. Let's try 20 plus 5m plus 12n plus 3mn. Okay, notice that there's no GCF. There's nothing that will come out of all four terms. So I'm going to try factor by grouping. I'm going to group these two together and these two together, making sure I have a plus sign in between there. Out of the first group, there we go, I can factor out a 5. And if I do that, what I have left is a 4 plus m. Out of the second group, I could factor out of here, I could factor out a what? A 3 and an n. 3n will come out of there. And if I do that, I will have left a 4 plus m. Okay. Now these terms are identical, and that's what you want here. If they weren't, then factor by grouping wouldn't be working for this problem. But they are the same, and so we move that 4 plus m out in front. There it is. The leftovers go in the other set of parentheses, which are right here. 5 plus 3n, and we have it factored. Let's try another. Example. R squared minus 9tw plus 3rw minus 3rt. All right. I'm going to group the first two terms together and the last two terms together. But no, I have a problem. I've come to a problem here. There's nothing that I could factor out of that first group other than a 1. And so what I'm going to do is I'm going to rearrange these. Sometimes rearranging works. So let me back up here. That obviously isn't going to work for us. So let's try this. Let's do some rearranging. I'm going to put the r squared and the 3rw together like that. R squared plus 3rw. And then I'm going to put the minus 3rt and then the minus 9tw there. Let's try that arrangement. Now I'm going to try factor by grouping. I'm going to group the first two terms together and the last two terms together. And always make sure that you have a plus sign in between. If there's a minus sign like there is there, make sure that it goes in the parentheses. That way you're always starting with a plus sign in between. Now let's see if rearranging them like this works. What can I factor out of the first group here? I can take an r out, and that leaves me with r plus 3w. Now out of the second group, I'm going to want to factor out a negative number. A negative 3 will come out of there, and also a t. I'm going to factor negative 3t out. And if I do that, negative 3rt divided by a negative 3t is an r. And a negative 9tw divided by a negative 3t leaves me with a positive 3w. Okay, it seems to be working because this term turned out to be exactly the same as that term. And so I'm going to factor it out in front, like I've been doing. There's the r plus 3w. And the leftovers, which are the r and the minus 3t, go in the second set, and we have it factored. There it is. Well, let's try one or two more of these. A cubed plus a squared minus 14a minus 7. All right, I'm going to group the first two together and the second two together, and make sure that you do put a plus sign in between. Remember, as I said on the last problem, if there's a negative sign here, make sure it goes inside with the term. Out of the first group, I could factor an a squared out, and that leaves me with a 2a plus 1. Now, in order to get another 2a plus 1 over here on the right side, I'm going to have to factor out a negative 7. Factor out a negative 7. If I do that, I will get a positive 2a plus a 1. And that's exactly what we want because these are now identical. So I factor the 2a plus 1 out to the front, and the leftovers go in the second set of parentheses. There they are, a squared minus 7, and it's factored. Okay, let's do one more example of factor by grouping. Let's try this one. 2ab squared minus 4 minus 8b squared plus a. Okay. If I try to factor this in the order it's given, all right, I'll put a plus sign in between, I can factor a 2 out of the front, but I have nothing other than a 1 that I could factor out of the second group, and this isn't working because this and this is not the same. So no good. This arrangement of terms isn't working for me. So like one of the previous problems, I'm going to have to take this polynomial and I'm going to have to rearrange the terms first. So I think what I'll try is putting the 2ab squared minus the 8b squared together, and then the a and the minus 4 like that. Okay, we'll try this arrangement. Usually there's usually a couple arrangements that will work. There's not just one right way. There's usually 2 or 3. Okay, now in this arrangement, I'm going to group these two together and these two together. I can now factor out a 2b squared out of the first group. If I do that, what I have left is an a minus 4. Out of the second group, since I want to end up with an a minus 4 again, what I'm going to do is I'm going to say I'm factoring a 1 out. I factored 1 out of the a minus 4, which leaves you with a minus 4. Now this arrangement is working because I have an a minus 4 here and an a minus 4 there. I'm going to move it out to the front, a minus 4, and the leftovers, which are the 2b squared plus 1, go in the second set of parentheses, and we have it factored. There it is, right there. And that is factored by grouping.